Let's denote the given definite integral by I. Now recall the property of definite integrals, that integral 0 to a f(x) dx is equal to integral 0 to a f of a minus x dx. Therefore, the given integral I can be expressed as integral 0 to pi upon 2, and replacing all x with pi upon 2 minus x, we get pi upon 2 minus x times sine of pi upon 2 minus x times cos of pi upon 2 minus x divided by sine of pi upon 2 minus x raised to the power 4 plus cos of pi upon 2 minus x raised to the power 4 dx. Now sine of pi upon 2 minus x is equal to cos x, and cos of pi upon 2 minus x is equal to sine x. Therefore, this becomes integral 0 to pi upon 2 minus x times cos x sine x dx divided by sine x raised to the power 4 plus cos x raised to the power 4. This can be broken into two components. The first component is equal to pi upon 2 integral 0 to pi upon 2 sine x cos x dx divided by sine x raised to the power 4 plus cos x raised to the power 4. And the second component is minus integral 0 to pi upon 2 x times sine x cos x dx divided by sine x raised to the power 4 plus cos x raised to the power 4. Note that the second component here is equal to I. Moving this to the left hand side, we get 2i is equal to pi upon 2 times integral 0 to pi upon 2 sine x cos x dx divided by sine x raised to the power 4 plus cos x raised to the power 4. Now divide both the numerator and the denominator of the integrand with cos x raised to the power 4. And therefore, 2i is equal to pi upon 2 times integral 0 to pi upon 2. The numerator can be rearranged as sin x upon cos x times 1 upon cos square x dx. And the denominator is equal to 1 plus tan x raised to the power 4. This is equal to pi upon 2 times integral 0 to pi upon 2 tan x times sec square x dx divided by 1 plus tan square x raised to the power 2. Now let tan square x is equal to u. Taking the derivative of both sides, we get 2 tan x sec square x dx is equal to du. Now when x is equal to 0, which is the lower limit of the integration, u is equal to tan square 0, which is equal to 0. And when x is equal to pi upon 2, which is the upper limit of integration, u is equal to tan square pi upon 2, which tends to infinity. Using these results, we get 2i is equal to pi upon 2 times integral u going from 0 to infinity, half du in the numerator, and in the denominator 1 plus u square. This is equal to pi upon 4 times tan inverse u, the limits being 0 to infinity. This is equal to pi upon 4 times in brackets pi upon 2 minus 0. And this simplifies to pi square upon 8. Therefore, the value of the given integral I is equal to pi square upon 16, which is the required answer.